All right, so curve sketching is about taking everything we know about how to analyze a graph, all of these different pieces to graphing, and putting them all together in order to graph or to sketch a function the best that we can. All of these are things that we have learned how to do, so I'm going to do a summary on each of them on this paper. But if you need more detail, you'd have to go back and look at the section where we first learned it. Asymptotes is section 3.5. Increasing, decreasing, and extrema is 3.3. Concavity and inflection points is 3.4. Intercepts have been an ongoing thing that we've been talking about over the past few years in algebra, so I wouldn't say there's a specific section where we've learned it this year, but we'll talk about the summary and how to do that. So you're looking for all of these things. If for some reason you couldn't find the x-intercepts, you can still move on and graph the function as best you can, but we want to try as best we can to get all of this information and put it together for an accurate sketch. So, quick review on intercepts. For intercepts, for x-intercepts, you would plug in 0 for the y variable and solve. That's going to give you where y equals 0 or where you have intercepts on the x-axis. For y-intercepts, very similar, but plug in 0 for x and solve. It says y-intercepts, but we're going to graph functions, so there should only be one y-intercept, or else it would fail the vertical line test. For vertical and horizontal asymptotes, quick summary on those. Vertical asymptotes, you set the denominator equal to 0 and solve. For horizontal, that has to do with end behavior, and you're going to analyze the powers or the degrees on the exponents on the top and the bottom. There's a whole summary on that section 3.5. Increasing and decreasing intervals in extrema, we get that information by applying the first derivative test. And if you recall, when the first derivative is positive, it's increasing. When the first derivative is negative, it's decreasing. And when the first derivative equals 0, there is a possible min or max. Remember, when we're looking for min and maxes, a minimum would be when it goes from decreasing to increasing. A maximum would go from increasing to decreasing. For concavity, it is the second derivative test. And with that one, it is looking at the second derivative, and if it is positive, it is concave up. If it's negative, it is concave down. Inflection points would be when the second derivative equals 0, there's a possible inflection point. And what you're looking for in inflection points is you're looking for when there is a change in concavity. So when it goes from up to down or from down to up. Those would be inflection points.